First off, as I go through these slides, you may want to pause each slide and read what is written on it before listening to what I have to say, because I'm not necessarily going to read the material on the slide. So in this video, I'm going to go through these slides in a little bit more detail. Feel free to just read through the slides yourself if you would rather, but there's some extra stuff that I don't have included in these slides directly. So our topic right now is on electric and magnetic forces and fields, but we can also just call this electromagnetic force. Now, if electromagnetic sounds familiar, that's the same thing that we talk about when we talk about light. Any sort of light from radio waves to gamma rays to visible light that you can see is electromagnetic, and these things work together. So when we discuss electric charges, we have two options, positive or negative. If the names of these sound familiar, protons and electrons, that's because there's something that you probably discussed in 7th grade when talking about chemistry. Protons and electrons are two of the 3 subatomic particles that make up atoms. When 2 or more charges interact, they either attract, pull each other together, or repel. This is a similar pattern that we're going to see in magnets, but when they have opposite charges, a plus and a minus, they're going to pull together, and when they have like charges, they repel each other. So opposites attract, like repels. We call electromagnetic force or electric force as an action at a distance force. That means that even when 2 objects are not touching, they exert force, or they try to move the other object. This is kind of governed by what we call field lines. Now, field lines are somewhat kind of understood thing to a point. We know that photons are kind of evolved in this connection, but at a basic level, we just know that when 2 opposite charges are alike, the field lines go together, and any other object kind of inside that field is influenced by those field lines. When 2 opposite charges are together, the field lines go apart, and same thing, any objects within that field interact with each other, and they're governed by that. One of the main ways that we see electric charges in our lives, other than the devices we use that use power, is through static electricity or static charge. So whenever kind of the weather conditions are right and you maybe shock someone, or things like styrofoam stick to an object, that's electric charge. And we just know that kind of we have 2 opposite charges, one object with more positive charge, one object with more negative charge. Because opposites attract, those 2 things pull together. When someone gets shocked, that is just kind of the charge going from one to the other, and we see it as essentially electricity. The other side of electromagnetic force is magnets. Now, unlike electric charges, which can be just positive or just negative, magnets always have both options. For magnets, we call it north and south, the same as the north and south pole on Earth, which is reflecting the magnetic field. Right? We call this a bipole, so it has to have a north and a south. People have speculated what we call magnetic monopoles, meaning they could have just a north or just a south, but that's not really something that we see practically. One of the cool things about magnets that makes them a little bit easier to understand than electric charge is that we can make and use magnets in our daily lives. Some materials can become magnets, such as iron, and when a strong magnetic field is put near that object, we essentially have, you can think, little tiny magnets in all the atoms that make up that material. And when a strong magnet is by it, all of those little tiny magnets inside the material line up. Right? In the right conditions, we can get this kind of lined up structure to stay, and we can make a magnet out of it. Like electric fields, we also have magnetic fields. These fields work the same way as electric fields, but the pattern can seem a little bit more complex because instead of just having plus or minus or north and south, all of our magnets have both. So we see the north attracting the south, and if we have the same thing like 2 north or 2 souths, we see them repelling each other. So just once again, how fields work in general, both electric and magnetic, since in a way they are kind of 2 parts of the same thing. Right? When you have an object that approaches the field lines, they don't need to be in contact with the magnet or the electric charge, right? Because these field lines are the things that make them move, attracting or pushing them away, right? One of the things that we say sometimes in physics is that, let's say if you were to touch something, like you touch the table, you're not truly touching it. And the reason why you're not truly touching it is the atoms in your finger and the atoms in the table are both repelling each other, right? So there's essentially an infinitely almost small gap in between, but those two surfaces are not quite touching. They're repelling each other the same way that two magnets with the same pole might repel each other. Thus, when your mom tells you to stop hitting your sibling, you can tell her that actually you weren't even touching them at all. So just to review, kind of previously in semester 1, we talked about a lot of contact forces. Friction, normal force, air resistance applied, like you're pulling something. We call these contact forces because at a kind of macro or big scale level, the two things have to be as much in contact as they can with each other to apply a force. Now, one of the coolest things with electric and magnetic, since, as I said earlier, they're essentially two ends of the same thing, they interact together. So electric current can be caused, or electricity can be caused to go through a coil of wire by the movement of a magnet, because that magnet essentially moves the electrons in that coil. Right? We can also use that to make things like electromagnets, all right? Or even things like electric motors use the same idea.